Welcome to Health Talk Made Simple by Aziz. In this video, we will explore two of the most critical jobs our kidneys perform every second of every day. First, we will uncover the fascinating process of how the kidneys produce urine, a function that is essential for cleaning our blood and removing waste. Second, we will learn how these same remarkable organs meticulously control the acid balance in our blood, a delicate equilibrium that is vital for the proper function of every organ in our body. Understanding these two fundamental kidney functions is not just an interesting biology lesson, it provides a crucial foundation for comprehending why kidney failure can become a life-threatening condition. When these jobs are compromised, the consequences can be severe, affecting everything from our breathing to our heartbeat. So, let's begin this journey together and understand this complex system, step by step, in a very simple way. So, what are the kidneys, and where are they located? The kidneys are two incredible bean-shaped organs, each about the size of an adult fist. They aren't floating around in our abdomen, they sit deep in the lower back, nestled on either side of the spine. They are well protected, tucked behind our lower ribs and the strong muscles of our back. Although they are relatively small, their impact on our overall health is immense. Think of them as the body's master chemists and purification plant. Their main job is to clean the blood, but their responsibilities don't stop there. They are constantly at work, managing the body's fluid levels, controlling essential salts and minerals like sodium and potassium, and, as we'll discuss in detail, ensuring the blood's acid level remains perfectly balanced. Every cell in your body relies on the kidneys to do their job correctly. To perform their cleaning duties, the kidneys need a constant and generous supply of blood. With every single heartbeat, about 20 to 25% of the blood pumped by the heart is sent directly to the kidneys. This blood reaches each kidney through a large dedicated blood vessel called the renal artery. Once inside the kidney, this main artery branches out into a complex network of smaller and smaller vessels, ensuring that blood is distributed throughout the entire organ. This steady, high-volume flow is what brings all the materials that need processing: water, salts, nutrients, and most importantly, waste products from the body's daily activities, to be filtered. Without this robust blood flow, the kidneys simply cannot function. Inside each of these small kidneys are about 1 million microscopic filtering units. These incredible structures are called nephrons, and they are the true workhorses of the kidney. Each nephron acts as a tiny, independent processing plant. The filtration process begins in a part of the nephron called the glomerulus, which is essentially a tiny tangled ball of blood capillaries. As blood flows through these capillaries, the pressure is just right to push water and small molecules out of the blood and into a surrounding cup-like sac. Larger components, like red blood cells and essential proteins, are too big to pass through the filter and therefore stay in the bloodstream. This initial filtered fluid is the very first step in the formation of urine. The fluid that has just been filtered, now called filtrate, contains a mixture of substances. It has the things our body needs to get rid of, like waste products from breaking down protein, such as urea, and waste from muscle activity, called creatinine. It also contains acids that need to be removed. However, this initial filtrate also contains a lot of things the body still needs, including a large amount of water and dissolved salts like sodium and potassium. The kidney's job now is to fine-tune this fluid. They must ensure that all the harmful waste is efficiently removed, but they also have to manage the levels of water and salts, removing only the excess amount to keep the body's internal environment perfectly stable. This is where the kidneys show how incredibly smart they are. They don't just throw everything away. As the filtrate flows through the long, winding tubules of the nephron, a remarkable process called selective reabsorption takes place. The cells lining these tubules are highly specialized to recognize and pull back exactly what the body needs to keep. They actively transport vital substances like glucose for energy, essential amino acids, and most of the water back into the bloodstream. They also carefully reabsorb the precise amount of salts, like sodium, needed to maintain healthy blood pressure and nerve function. Only the unneeded substances, the true waste products and any excess water and salts, are left behind in the tubule. This selectivity is crucial for protecting our body's delicate balance of fluids, energy, and electrolytes. After this intricate process of filtering and fine-tuning, the liquid that remains in the tubules is now officially urine. This final product is a concentrated solution containing the substances the body needs to discard to stay healthy. It is primarily composed of water, but dissolved within it are the metabolic waste products like urea and creatinine, excess salts that the body didn't need, and acids that were removed from the blood. The production of urine is the body's primary and most effective method for safely disposing of these potentially toxic substances. By creating urine, the kidneys ensure that our internal environment remains clean, balanced, and stable, a state known as homeostasis. Once formed, the urine doesn't just stay in the kidneys. It is collected and then leaves each kidney through a narrow muscular tube called the ureter. The ureters act as one-way conduits to the bladder. They don't rely on gravity alone. Gentle, wave-like muscular contractions, known as peristalsis, actively push the urine downwards, ensuring a constant flow. The urine is carried to the bladder, which is a hollow, muscular organ that serves as a temporary storage reservoir. The bladder can expand to hold the urine until it is convenient to empty it. When the bladder becomes full, it sends signals to the brain, and when the time is right, urine exits the body through another tube called the urethra. This entire system works quietly and efficiently, day and night, to keep our body clean. Now let's shift to the second vital job of the kidneys, managing acid. It might be surprising to learn that our bodies naturally produce a significant amount of acid every single day. This acid comes from several sources. A primary source is our diet, particularly from the digestion and metabolism of proteins found in meat, fish, and other foods. Another major source is physical activity. When our muscles work hard, they produce lactic acid. Finally, even the normal, everyday chemical processes that keep our cells alive and functioning, collectively known as metabolism, generate acid as a byproduct. Because this acid production is a constant, ongoing process, the body must have an equally constant and effective way to either neutralize it or remove it to prevent a dangerous buildup. The kidneys are the primary regulators of acid in the body, and they tackle this challenge in a couple of brilliant ways. The first and most direct method is by removing acid from the blood and excreting it into the urine. The cells of the kidney tubules can actively pull acid in the form of hydrogen ions out of the bloodstream and secrete it directly into the fluid that is becoming urine. This process is incredibly dynamic. The amount of acid the kidneys remove changes from hour to hour and even minute to minute. It adjusts based on your diet, your level of physical activity, and your overall health. This continuous adjustment is what allows the kidneys to maintain a precise acid-base balance in the blood, despite the constant production of acid. Removing acid is only half the story. To provide a complete defense against acidity, the kidneys also add a substance called bicarbonate back into the blood. Bicarbonate is a base, and it acts as the body's own natural antacid. It circulates in the bloodstream and works as a buffer, meaning it can absorb and neutralize excess acid on the spot, preventing sharp changes in blood acidity. The kidneys not only reabsorb the bicarbonate that was initially filtered out of the blood, but they can also generate new bicarbonate when the body needs more. By masterfully combining these two actions, actively removing acid from the blood and simultaneously replenishing the blood supply of bicarbonate, the kidneys ensure that the blood's pH is kept within its healthy, incredibly narrow range. Why is this control of blood acidity, or pH, so critical? It's because nearly all the essential functions in our body are exquisitely sensitive to pH. Our organs, enzymes, and cells are designed to work properly only when the blood pH stays within a very tight range, ideally close to 7.4. Even tiny deviations from this range can have profound effects. If the blood becomes too acidic or too alkaline, it can impair how our brain thinks, disrupt how our heart beats, and weaken how our muscles contract. The body has a three-part defense system to prevent this. Buffers in the blood like bicarbonate, the ability of the lungs to blow off carbon dioxide, and, most powerfully, the kidneys. They all work together, minute by minute, to keep our pH stable and our body functioning correctly. Now that we understand these two vital jobs, we can see what happens when the kidneys fail. If the kidneys stop making urine, or make very little, the consequences are immediate and serious. Without urine output, the body cannot get rid of waste products, and they begin to accumulate in the blood to toxic levels. Simultaneously, the body cannot remove excess fluid. This fluid begins to build up in the body's tissues, a condition called edema. Swelling often appears first in the legs, ankles, and face. More dangerously, fluid can collect in the lungs, a condition called pulmonary edema, which makes breathing extremely difficult. Blood pressure often rises to dangerous levels, and without treatment, a person's overall health can decline very quickly. In addition to fluid problems, when diseased kidneys can no longer remove enough acid or produce enough bicarbonate, acid begins to build up in the blood. This dangerous condition is called metabolic acidosis. The initial symptoms can be subtle. People may feel unusually weak, tired, or nauseous. As the acidosis worsens, a key sign is a change in breathing. The body desperately tries to compensate by getting rid of acid in the form of carbon dioxide, leading to rapid, deep breathing. This is the lungs' attempt to help, but they can't fix the underlying problem. If left uncorrected, severe acidosis can destabilize the heart and impair the function of all major organs. It is a serious medical emergency. In cases of severe kidney failure, several of these dangerous problems can happen all at the same time, creating a perfect storm inside the body. Fluid overload puts immense strain on the heart and lungs. Metabolic acidosis disrupts cellular function throughout the body. And another life-threatening issue arises: the buildup of potassium. Healthy kidneys are responsible for removing excess potassium from the blood. When they fail, potassium levels can rise to very high levels, a condition called hyperkalemia. High potassium is particularly dangerous because it can severely disrupt the heart's electrical rhythm, potentially leading to a fatal cardiac arrest. The combination of these problems requires urgent medical attention. When a person's kidneys can no longer perform their essential jobs, doctors may recommend starting dialysis. Dialysis is a medical procedure that artificially performs the functions of the failed kidneys. It is a life-sustaining treatment. During dialysis, a machine is used to remove the accumulated waste products, like urea and creatinine, from the blood. It also precisely removes the excess fluid that is built up in the body, relieving swelling and pressure on the heart and lungs. Furthermore, the dialysis treatment helps correct the acid-base imbalance by removing acid and replenishing bicarbonate. While dialysis does not cure kidney disease, it can effectively manage the symptoms and keep patients stable and living their lives while other treatments, like a kidney transplant, are considered. Thank you for watching Health Talk Made Simple by Aziz. We hope this detailed explanation of how the kidneys make urine and control acid has been clear and helpful. Understanding the why behind kidney health is the first step toward better managing it. If you found this information valuable, please consider sharing it with friends, family, or anyone who might benefit. And please stay tuned for more videos from our series covering topics like kidney failure, the different types of dialysis, and how to maintain good kidney health.